Welcome back to Maths in an Empty Classroom with me, Mr. Summer. This is part 2 of the video on hypothesis testing, and in this video I'm going to be going through an example of a two-tailed test. Okay, so here we go. We have in 1918 it was noted that 3% of the UK population were left-handed. To see if this proportion has changed, a sample survey is carried out. The survey uses a sample of 80 people, and it was found that 7 people were left-handed. Using a 5% level of significance, test whether or not there has been a change in the proportion of the UK population that are left-handed. Now, the key word in this example here is change, because whereas in the previous one we were asked about whether things had improved, so the probability of a fault had decreased, here we're just being asked if there's a change. We're not being asked is it a change increase or a change decrease, it's just a change. And this is the word that implies that what we are going to do is a two-tailed test. And what that means is we look at the significance level of 5% and we look for a 2.5% at one end and 2.5% at the other end. So we halve the significance level and we work with that. So what we're going to do then is we're going to look at null hypothesis, alternative hypothesis to set up this problem. So it's been noted that 3% of the UK population were left-handed. So our null hypothesis is going to be that the probability of being left-handed is 0.03. Now, here's the first important change. Our alternative hypothesis, rather than in the previous example where it was either going to be greater than or less than, this one is that it is not 0.03, so not equal to 0.03. To test this, we're going to use the sample given, so n is 80 and the probability is 0.03. So we're going to define the distribution that we're using. The x follows the binomial 80, 0.03. Now, even though it's a two-tailed test, we're not actually going to test both tails, because we're not going to say what's the probability of less than or equal to 7 and what's the probability of more than or equal to 7. We're going to make a choice based on what we'd see with the probability. Now, if 3% of the UK population were indeed left-handed, then our expectation would be 3% of 80, which is 2.4, 0.03 times 80, some people say NP. So if our expectation is that 2.4 of these people would be left-handed, the fact that 7 of them are left-handed, clearly, if the probability has changed, it's got bigger. So what we're going to do now is we're going to write our rejection statement, and we would reject H0 if the probability of x being greater than or equal to 7 was less than or equal to 0.025. And I've got that from halving the significance level because it's a two-tailed test. That's the biggest mistake that people make. They look at the significance level and they don't realise it's a two-tailed test and they use a significance level that's too big. So what I'm now going to do is work out the probability that x is greater than or equal to 7 for the binomial distribution 80, 0.03. Now the probability that x is greater than or equal to 7 is going to be 1 minus the probability that x is less than or equal to 6. Because I want the probability of getting any result between 7 and 80, which means I need to take away the probability of getting any result between 0 and 6. Using the distributions function on my calculator here, I've got that the probability of getting less than or equal to 6 is 0.9896. So what I'm going to do with that is store that value in my calculator using the alpha store and work out 1 minus from there, which is 0.0103. So the probability of 7 or more people being left-handed is 1.03%. And I'm going to compare that with the significance level of my test, which is 0.025. So 0.0103 is less than 0.025. So smaller than my significance level. So it means what's happened is unlikely enough that I can doubt my assumed probability. So I'm going to reject H0. And I'm going to say there is evidence to suggest that the proportion of left-handed people has changed. Just talking a little bit further about hypothesis testing, you're sometimes asked about what is the significance level. Well, the significance level is the chance of incorrectly rejecting your null hypothesis. So it could well be that in this example, I've got this result of 7 out of a sample of 80, but actually for the whole population, the probability is still 0.03. Because this chance here of just over 1%, it doesn't mean it's impossible for me to get 7 left-handed people out of a sample of 80. So there is a chance that I have incorrectly assumed the probability to be wrong, and that's why we have a significance level. So the lower this value is, the less likely the thing is to happen, and the more confident we can be in rejecting the null hypothesis. Thanks very much.